Hello my dear students, welcome to IMS Academy Network Theory Previous Year Question Session 3. So in the previous two sessions we have discussed the SSC JE questions which are asked in the previous years regarding network theory subject. So regarding that we have done two sessions earlier. Whoever not watched those sessions, kindly all of you watch in your free time. Okay, in those sessions I have discussed the network theory questions based on the concepts like with respect to sources and then with respect to passive elements like resistors, inductors, capacitors, right? And then we have discussed the questions based on KCL, KVL, etc. Okay, so even we have discussed some of the basic laws also in addition to KCL and KVL, right? And in this particular session we are continuing further regarding the further questions or continuation concept based questions, the questions which are asked in the previous years of SSC JE, right? And whoever watching very first time in our YouTube channel, okay, so all of you kindly subscribe our YouTube channel, okay, and then click on the bell icon so that you will be getting instant notifications whenever we are uploading the upcoming videos, okay. And all of you kindly like and share this video link with all of your friends so that they also will attend this session and they also will get benefited from this particular session, okay. So before going to start the session, I am going to give one important update for all of you. That is our Telegram channel, IMS Academy Telegram channel. Regarding the link already provided in the description of this particular video, it is free for everyone. All of you kindly join. If you not yet joined, kindly join in your free time. Okay. So in this Telegram channel, say for example, whatever we are writing currently during the class, this particular notes we will be sharing in the PDF form. Okay, that PDF we are sharing in this particular Telegram channel, right? And you are getting all the important updates whenever we are conducting any seminar or webinar. Even you are getting all the government job notification updates also you are getting in this Telegram channel. And on daily basis you are getting one opportunity, on one quiz question on daily basis, right? So all these benefits you are getting for free of cost. All of you kindly join. Okay, right. So in this particular session, this is the third session regarding the PYQ series of network theory subject with respect to SSC JE PYQ questions, right? So in this particular session, I am going to cover the questions based on these concepts, okay? In the previous class also we have discussed with respect to KCL and KVL. Even in this particular session also we are having good number of questions I am going to cover. And then with respect to current division rule also we are going to cover the questions. And then with respect to nodal analysis, and then wherever required we will apply source transformation also. And with that the first chapter will be completed, and then we will discuss regarding network theorem based questions also in this particular session, okay. Yeah, so this is the question asked in SSC JE in the WE paper in the year 2022, okay. So here in this particular question you are having the circuit diagram like this, okay. Here you have to find out the current flowing through 61 ohm resistor, okay. Here you are having 61 ohm resistor. In this 61 ohm resistor the current direction mentioned like this, top to down, okay. So this current value we have to calculate, okay. So just if you carefully observe here, okay, here in this particular branch 15 ampere current is entering. In this particular branch 15 ampere current is entering, right? And in this branch and in this branch together 3 IR current is leaving, right? So that means we are applying KCL at this particular node. At node A we are applying KCL, okay. So by applying KCL, here net current leaving is 3 IR. Direct step I am writing because we have done good number of questions in the earlier classes, okay. I hope all of you are getting the clarity. Sum of leaving currents equal to sum of entering currents, okay. IR plus 2 IR, that is 3 IR, is equal to 15 ampere. So here in this case 3 5 times, so that means you are getting IR equal to 5 ampere, IR equal to 5 ampere, right? Yes, we are having in option D, okay. Just with the help of KCL you are getting directly the answer, okay. So whenever you are applying KCL, okay, just observe the circuit diagram, okay. You can do the calculation without using pen and paper. Just for understanding purpose I have done, okay, right. So all of you give a try for the next question. in this question you have to calculate the V naught value. Okay, all of you give a try. Yeah, in this question you are having V naught is nothing but voltage that is across 4 ohm resistor. Okay, right, that we have to calculate. V naught across 4 ohm resistor. Okay, so here also you can observe here in this particular branch, 0.5 I naught current is entering. Okay, and in this branch I naught current is leaving, and in this branch 3 ampere current is entering. So that means you can apply KCL at this particular node. In these two branches currents are entering. So I am applying once again KCL. So here 0.5 I naught and 3 ampere both are entering. So sum of entering currents is equal to sum of leaving currents. Here I naught current is leaving. Right. So here 0.5 I naught we can bring to the right hand side, it will become negative. So I naught minus 0.5 I naught, that means you are getting 0.5 I naught is equal to 3. I am repeating once again, this positive number I have brought to the right hand side, it will become negative. So I naught minus 0.5 I naught is nothing but 0.5 I naught, that is equal to 3. Okay, so 0.5 we can write as 1 by 2. So from here you are getting I naught equal to 3 into 2, that is nothing but 6 ampere. See, 0.5 you can write as 1 by 2 and then we are doing cross multiplication. Okay, right. So 6 ampere, that is your I naught. I naught is 6 ampere, but in this question we have to calculate V naught. Okay, so just you have to apply Ohm's law, that's all. V naught equal to, here resistor value is 4 and current value is I naught. So just now we got current value as 6 ampere, so you can substitute 4 6 are 24, units are volts. Okay, the voltage across 4 ohm resistor is 24 volts. So here you are having in option C. So in this way, whenever you are solving any network theory question, if you are having circuit diagram, just observe the circuit diagram. Okay, if you have observed the given circuit elements and what values they have given, okay, just observe the elements and the given data. From there you are getting a clue which law we have to apply. Okay, right. Yes, next question. So in this question they are asking the power delivered by voltage source. Okay, in this circuit diagram you are having 2 current sources and 1 voltage source is there, right? With respect to this voltage source, they are asking how much power delivered. Okay, whether it is delivering the power or absorbing the power, that will decide in some time. Okay, so ultimately with respect to this voltage source we have to calculate the power, right? Okay, so here also you can observe, here in this branch 2 ampere current is coming, and in this branch 5 ampere current is coming to this particular node. Yes or no? In these two branches together 2 ampere and 5 ampere, together 7 ampere is coming, so that entire 7 ampere should leave like this. Yes or no? If 7 ampere current is coming to this particular node, together 7 ampere can go like this. Okay, so now you can observe, here with respect to voltage source you are having positive sign here and negative sign, polarities, plus sign, minus sign, right? Now just observe, current enters where? Positive terminal. Whenever current enters positive terminal, whether that element is delivering the power or absorbing the power, all of you all of you mention your answer in the comment section. Whenever current enters at positive terminal, whether that element is delivering the power or absorbing the power. Yes, it is actually absorbing the power, because just like your resistor, okay, in the resistor current always will flow from positive polarity to the negative polarity, or in other words we can say current flows from high potential to the low potential, right? So since current enters at positive terminal, actually this particular source is absorbing the power, right? So here in this case the voltage source is absorbing the power. Okay, So power formula is simple, the product of voltage and current. Okay, in this case voltage value is 2 and the current value is 7. Okay, so 2 7s are 14. If they have asked the power absorbed, then the answer will be 14 watt. But in this question they have asked delivered power, so that means delivered power is nothing but minus absorbed power. So since you got here 14 watt, so the final answer will be minus 14 watt. Minus 14 watt. Okay, so option A is correct one. So in this way, be focused whether that particular source is delivering the power or absorbing the power. See, whenever in the given circuit, if you are having only one source, definitely that source will deliver the power. But whenever multiple sources are present in the given circuit, based on the network elements connected, okay, some sources can deliver the power, some sources can absorb the power, right? So whether it is delivering or absorbing, it is purely depend on the sign convention. If current enters at positive terminal, that means it is absorbing the power. If current leaves from positive terminal, it is delivering the power. Okay. If you want to get good command regarding the power absorbed or power delivered, if you want to get good command, okay. So we have done the foundation course regarding network theory subject earlier in our YouTube channel, right? All of you just visit the playlist regarding network theory subject foundation course. In that foundation course, I have discussed the basic concepts like types of network elements, and then basic laws like KCL, KVL, etc. we have discussed. Okay, with respect to the first chapter basic concepts, I have covered there. So with the help of those concepts, while you are studying the other concepts of first chapter, even other chapters of network theory subject, you can easily understand, because all the advanced chapters basis on the foundation, that means the basic laws like KCL, KVL, etc. right? Okay. Yeah. Next question. So in this question, you are having a circuit diagram like this. Okay. So in this question, you are having supply voltage is 160 volt. Okay. The value of the power dissipated in the 10 ohm resistor. Okay. Here you are having the 10 ohm resistor. In this particular resistor, how much power is dissipated? Okay. Right. So here you can observe in this entire circuit you are having only one supply and then you are having resistors, right? Okay. Obviously this source is delivering the power, whereas all the resistors definitely they will be absorbing the power. Okay, right. So here first let us calculate, okay, regarding the equivalent resistance of these two. I hope all of you can calculate 10 ohm in parallel to 15 ohm. How much you are going to get? 10 ohm in parallel to 15 ohm. So that is nothing but 10 into 50, 10 into 15 divided by 10 plus 15. 10 into 15 divided by 10 plus 15. So 15 tens are 150 divided by 10 plus 15 is 25. So here 25 6 times. So that means you are getting 6 ohm. 6 ohm. This entire equivalent resistance is 6 ohm. Okay. Now all these three resistors, here you got one single resistor, right? 6 ohm. 6 ohm, 4 ohm, 6 ohm. All are connected in series. In series we can add the resistors, right? So 6 plus 6 is 12, 12 plus 4 is 16. Okay. Now in this circuit, in this closed path, how much current is flowing? That we can easily calculate, right? So I equal to supply voltage is 160 divided by sum of all these resistors, right? 6 plus 6, 12 plus 4, that is 16. Direct step I am writing because we have solved good number of questions. Okay, right. So here you are getting 10 ampere. In this branch, 10 ampere current is flowing. Okay. Now you can apply. Okay. So if you want, you can apply current division rule. That is one approach, or otherwise one more easy approach here I am discussing. Here 10 ampere current is flowing. So here these two resistors we can sum together because they are connected in series, right? So here you are getting 10 ohm, 10 ohm, and just now we got 10 ampere. Just now we got 10 ampere here. So by using Ohm's law, you are getting 10 into 10, that is 100 volts. 100 volts. Okay. So here just now we got 10 ampere, I am substituting here. Okay, now just we are calculating what? The voltage across 10 ohm, voltage across 15 ohm, both are same because these two resistors are connected in parallel. In parallel voltage will be same. Okay, so now I want to calculate the voltage across 10 ohm resistor. Okay, now you can observe you are having supply voltage and then one more voltage you got just now, and then we have to calculate this voltage. Okay, if you want you can apply KVL like this, you can apply KVL like this, or otherwise in the last class also we have discussed, in order to find the unknown voltage whenever you are having the closed path, okay, I have discussed one representation or notation. Based on that approach you can easily get the answer also. Okay, so just for easy understanding I am repeating that model once again. You can observe here you are having the supply voltage polarities are plus minus, supply voltage polarities are plus minus, so you are having 160 volts. Okay, and here just now you got plus minus. Okay, I will represent once again there. Yeah, so here we are having plus minus 160, plus minus 160, and whatever this horizontal you are having 100 volts, for the timing I am representing vertical, then you are getting the polarities are, you are getting minus plus, you can observe here plus plus, yes, and then minus is coming top and this value is 100. Now just observe here voltage polarities are opposite, that means we have to subtract, this value is large when compared to this one, right? So obviously this polarity you are getting, so 160 minus 100, that is 60 volts, Now you can observe here for the time being I have labeled this particular node as A. Okay, suppose this node as B, example. Okay, so here you can observe this node, all are same, right? So I am considering that, suppose here I am labeling the same node B, just for easy understanding. Okay, between A and B, to the left hand side we are getting 60 volt, and to the right hand side you are having this resistor configuration. Obviously in parallel voltage should be same, so that means voltage across this 10 ohm resistor is nothing but 10 volt. Okay, so for easy understanding I am representing this is nothing but VAB. VAB is nothing but 60 volt. Okay, now you got the voltage across the resistor. Now we can calculate the power dissipated. Okay, so now we are calculating the power dissipated in 10 ohm resistor. Power dissipated in 10 ohm resistor. Power dissipated in 10 ohm resistor, that is nothing but V square by R. Just now we got V. Okay, you can use here V square by R. So in this case VAB square divided by R. Okay, R value is 10 ohm. Accordingly we can substitute. Okay, so VAB just now we got 60 volt. Okay, so for the timing I am writing like 60 into 60 divided by 10. So here 1 0 will get cancelled, right? Then 6 into 60 is nothing but 360, units are watts, 360 watt. Okay, so that means here we are having option D. Option D is the correct one. Okay, in this way just observe the circuit diagram. Wherever simplification is possible with the help of resistances, there you can do the equivalent resistance. Okay, and after that based on the requirement you can apply KCL or KVL or Ohm's law, whatever the laws. Okay, with the help of whichever law you can solve the question in simpler way, better you can follow in that manner. Okay, right. Yeah, next question. Yeah, just observe here in this question you are having the circuit diagram like this. Okay, so in this question we have to calculate the current flowing through 1 ohm resistor. Here you are having 1 ohm resistor. In this particular resistor how much current is flowing, that is the question. Okay, this is a very interesting. Here actually in this circuit, generally in the any question or any circuit diagram, whatever we are supposed to find, that unknown they will represent in the circuit. But in this question there is a surprise. Here I they have represented, but anyway that I here in the question nowhere we are not using in terms of I anywhere. Okay, but surprisingly intentionally they have given. Okay, because sometimes few people will be in hurry mode. Okay, the moment they are calculating I value, that option will be there in the given choice also. Okay, that answer will be there in the given choices. In hurry mode they may be choosing that answer, but here they are not asking with respect to 4 ohm how much current is flowing. Rather they are asking in the 1 ohm resistor how much current is flowing, right? So this is the most interesting thing and important thing in this question. Okay, otherwise this question is dead easy, simple question only, but this is the trap in this question. Okay, so now just observe, here you can apply KCL at this particular node, you can apply KCL. In this branch the current I is coming or entering, and in this branch 2 ampere current is entering. So together, because in both the branches currents are entering, obviously in this branch current should leave, right? So that means here the resultant current will be I plus 2. Now you know the current, you know the resistor, we can apply Ohm's law in order to find the voltage. Similarly here also we can apply Ohm's law. Okay, so I into 4 is nothing but 4I, right? Here 1 into I plus 2, that is nothing but I plus 2. Okay, now you can apply KVL around this closed path. Just apply KVL around this closed path. So here minus 2 plus 12 volt, then plus 2 minus 4I, then once again plus 2 minus of I plus 2 is equal to 0, right? So here you can observe 4I, here I am taking, say for example, from these two, or otherwise first you do simplification with respect to the constants. Okay, 12 minus 2 is nothing but 10. 12 minus 2 is nothing but 10. Okay, now here you can observe 4I minus I, that is nothing but minus 5I. I am bringing to the right hand side, it will become positive. So here 5 2 times, that means I equal to 2 amperes. Okay, in this question the moment you are getting 2 ampere, here you can observe that 2 ampere is also there in one of the choice, but 2 ampere is not correct. The reason is, in this question if they ask you to calculate the current flowing through 4 ohm, then obviously 2 ampere is correct, option B. But in this question they have asked the current flowing through 1 ohm resistor, 1 ohm. Okay, so here the current flowing through 1 ohm resistor is I plus 2. Okay, the current flowing through 1 ohm resistor is nothing but I plus 2, and just now you got I value 2, you can substitute here, 2 plus 2 is nothing but 4 ampere. Okay, that is a twist in this question. Okay, I hope all of you are getting the clarity. So for this question, option A is the correct one. Okay, all of you give a try. The next question. Yeah, just observe, in this question you are having a circuit diagram like this, and in this question you have to calculate the current IA, current value IA you have to find out. Okay, so just like the earlier questions, here also you can apply KCL. You can apply at this node or at this node, your wish, no issue. Okay, ultimately you will be getting the same answer. Okay, say for example, here in this branch the current IA is entering. Similarly, in this branch, the current 3 times IA is entering. That means in both the branches, currents are entering. The net current entering is what? 3 plus 1, that is 4. Obviously, the entire current should leave like this. See, in this question, even in the earlier question also, sometimes whether, say for example, in this question, they have mentioned IM. Okay, anyway, IM they are not asking. okay, but sometimes intentionally they are making you confusion, okay. No need to follow, okay. Suppose if you are not using that one anywhere, if there is no requirement, you can ignore that notation, okay, right. So here in this question, actually the current is flowing like this, okay. So since the current is flowing like this, now by using Ohm's law, 4 into 2, that is nothing but 8 into Ia, the voltage across 2 ohm resistor is like this, okay. And in this particular branch, okay, because the current direction is like this, that means the current Ia is flowing like this, right. Now by using Ohm's law, you are getting 4 times Ia, okay. Now just you have to consider the external closed path, okay. If you want, you can consider clockwise, or if you want, you can consider anti-clockwise, your wish. Just I am considering the outer closed path, and for that outer closed path I am applying KVL, okay. For this outer closed path I am applying KVL, okay, right. Now here minus to plus, that is plus 12, then minus to plus 4 times Ia, then minus to plus 8 times Ia. That's all, right. Only 3 elements are there, okay, is equal to 0. Now 4 plus 8 is 12 Ia is equal to, I am bringing this one to the right hand side, obviously it will become negative. So here 12 one time, okay, but here you are having minus sign, so that means Ia equal to minus 1 ampere, right. So answer for this question is option A. In this question we have to calculate the current Ia, so the value is minus 1 ampere, option A is the correct one. Actually here if you observe closely, whatever the question, actually I have discussed this question with the simpler manner. First I have applied the KCL and then I have applied the KVL for outer loop. But can you recall what is actually the other name? If you want to give the other name, like whatever the method of solving we have done here, if you are combining, okay, then we have used one concept. Can you mention that answer in the comment section? Here if you observe, you are having one mesh, here you are having one more mesh, right. 2 meshes are there, but for both the meshes you are having current source is the common for both the meshes, but we don't have the voltage across it, okay. If you want to write the mesh equation here and then mesh equation here, with the help of 2 mesh equations you cannot solve 3 unknowns, right, because here you don't know the voltage across this particular current source. That is the reason we have to use the concept of super mesh, okay. So whenever you are writing super mesh, we are just you have to remove the current source from the given circuit, then you are getting the closed path, there you are writing KVL, and okay, and here you either at this node or at this node you are applying KCL, okay. So here while you are writing the mesh equation, okay, you are using 2 laws like KVL and Ohm's law, and then here you are applying KCL. Actually you are using the concept of super mesh, okay. I hope all of you are getting the clarity, okay. Generally students will get fear whenever you are having super node or super mesh, but see ultimately you are using the basic laws, that's all, okay. But if you are having interest, then even though the tougher concepts or bigger concepts you can easily apply, provided if you are having the interest, okay. I hope all of you are getting the clarity how easily we are able to solve this question, okay, right. So if you want, just for reference I am mentioning here, actually this kind of questions while you are solving you are using the concept of super mesh, just for reference I am mentioning here, okay, right. Yeah, next question. In this question we have to calculate the current value I, the value of the current I, okay. So here in this question the current I is present here, that current I we have to calculate, okay, right. So once again see, just observe all these questions we are using the same concept KCL only with the help of the basic laws, because sometimes people will think network theory subject is so tough, but if you are very much good with respect to the basic laws and if you are able to observe the circuit diagram in the best way, definitely most of the questions you can easily solve with the help of basic laws. Okay, right. So just observe here in this question also, the current I is entering here, the current I is entering, okay, and in this branch 5 ampere current is entering. So that means both the currents are entering, right? Obviously in this branch the current I plus 5 is leaving. Yes or no? I and 5 both are entering together, I plus 5 is leaving, right? Now once again I am using Ohm's law here. The current I is entering and 2 ohm resistor, that means 2 into I, 2 into I. And here I plus 5 is current flowing. So by using Ohm's law, you are getting 3 into I plus 5. 3 into I plus 5. Okay, right? So here first step I have applied KCL at this particular node. Now after that, for every element, wherever you are having resistor, you know the current and you know the resistor. By using Ohm's law, we are getting the voltage. The moment you got like this, now you can apply KVL around the outer loop. That's all. KVL around outer closed path. That's all. And here also, if you observe, this question is also like super mesh concept. Okay, just for your reference, I am mentioning this question also. You'll be solving by using super mesh concept. Okay, right. Now minus to plus, that is plus. Okay, so here I am writing the KVL, minus to plus, that is plus 20, then plus to minus, minus 2I, minus 2I, then plus to minus, minus 3 into I plus 5, 3 into I plus 5, then once again plus to minus, minus 3I is equal to 0. Minus 3I is equal to 0. Right. So just observe here. Here minus 3 into 5. Okay, minus of plus is minus, 3 into 5 is 15. Right. So plus 20 minus 15 is nothing but plus 5. Plus 5. Right. And remaining all the terms with respect to I, you are having negative, that we can bring to the right hand side, it will become positive. Okay. So here 3I, then 3I, that is 6I, then 2I, that is 8I. So 5 equal to 8I. From here you are getting I equal to 5 by 8. Units are ampere. I equal to 5 by 8 ampere. In this question we have to calculate the current. Yes, we are having in option A. Option A is the correct one. Okay, all of you give a try for the next question. In this question also we have to calculate the current value I. Yes, just observe here. If you want whatever the procedures earlier we have discussed, you can apply similar procedure also. Okay, but just for variety, here I am discussing another approach. So here we have to calculate the current flowing through 1 ohm resistor, right? So that 1 ohm resistor is present between these two nodes. The 1 ohm resistor present between these two nodes. Okay, now if you carefully observe, in order to do the calculation simpler, can we apply any technique here? Yes, you are having current source in parallel to resistor, so we can apply source transformation technique. Okay, if you apply source transformation technique, okay, we can apply source transformation technique. If you apply that one, we can convert practical current source into practical voltage source, right? So here we will be getting, okay, 2 ohm resistor, okay, as it is. Okay, now just do the multiplication of these two. That means just we are applying Ohm's law, that's all. Current into resistance, so 3 into 2, that is nothing but voltage. So 3 2s are 6 volts. See, it is very simple. Here current direction is what? Upward. Whenever you are having voltage source, current will leave from positive terminal. So accordingly you can represent the polarities, that's all. Okay, In this way, if you are having current source in parallel to resistor, we can represent as voltage source in series with resistor. Okay. Right. Okay. Now, whatever the circuit here to the left of the terminal, okay, here right hand side circuit we have replaced like this. Okay. Now, left hand side circuit you can copy as this. Here you are having 1 ohm resistor, then 12 volt source. Okay. Right. I hope all of you are getting the clarity. Now, just if you observe, in this question the current direction is like this. Okay, I am representing as it is, no problem. Whatever the current direction is given, let us consider. Okay. Now, these two resistors are connected in series. In series, we can add the resistors 1 plus 2, that is nothing but 3. Now, you are having one voltage source here, other voltage source, right? Now, you can use Ohm's law, that's all. I equal to 6 minus 12 divided by 3. So, 6 minus 12 is minus 6 divided by 3, that is nothing but minus 2 ampere. Minus 2 ampere. Okay. So, that means option D is the correct one. Okay. In whichever question with the help of source transformation technique, you can solve the question in simpler way and in less time, better apply there. Okay. And one more important note, whenever you are applying source transformation, okay, the response means either current or voltage. That particular branch element position should not disturb. Say for example, in this question, you are having, for the timing I am labeling this point as C and this point as, say for example, B, example. Okay. So, here between the points A and C, we are having the resistor 1 ohm as it is. The terminals are not at all modified. Okay. And to the left of the terminals A and B, what is circuit? As it is we have kept, and to the right of the circuit, to the right of the terminals A and B, we have replaced the equivalent circuit. Okay. That is the most important thing. Okay. Suppose here you have to calculate the current I, here you should not apply source transformation, because if you apply, the terminals are going to change. Okay, that is the reason where you are supposed to find the response, there you should not apply source transformation. Okay, I hope all of you are getting the clarity. Okay, right. Next question, all of you give it a try. In this question, you are having the circuit diagram like this, okay, and here we are supposed to calculate the voltage across current source. Okay, just observe the circuit diagram. Here you are having current source. Across this current source, we have to calculate the voltage, right? Now, here if you observe, these two are connected in parallel. Okay, we can find the equivalent resistance. 6 into 4, that is R1 R2 divided by R1 plus R2. R1 plus R2 means 6 plus 4, that is 10. Okay, 6 4s are 24 divided by 10, that is nothing but 2.4 ohm. Okay, this entire equivalent resistance is nothing but 2.4 ohm. Now, here you got one single resistor 2.4 ohm, and here you are having 2 ohm resistor. These two are connected in series. In series, we can add the resistors, right? So, 2 plus 2.4 ohm, that is nothing but 4.4 ohm. So, that means this entire circuit we have replaced with one resistor, and it is having the value 4.4 ohm. Now, whatever this 5 ampere current is there, the entire 5 ampere current is flowing in this particular resistor. Yes or no? Entire 5 ampere is flowing in this particular resistor. Okay, now you can apply Ohm's law. Okay, just for easy understanding, I am representing like this. Okay, here you are having 5 ampere, and this entire equivalent resistance just now we got 4.4 ohm. Now just apply Ohm's law, that's all. Here 5 ampere current is coming like this. Now by using Ohm's law, you are getting voltage across this one is 5 into 4.4. Okay, 5 4s are 20, then 5 4s are 20 plus 2, 22. So 22.0, that is nothing but 22 volts. 22 volts. And with respect to current source, the voltage polarities are same, plus minus. Yes or no? Because when you're having the source, only one source, obviously that source is delivering the power. Okay, the current should leave from positive. Yes, polarities are same. Okay, so in this way, whatever the 22 volts you got with respect to the resistor, the same 22 volts will present across the 5 ampere source. Oh, right? So the answer for this question is option B. Option B is the correct answer. All of you give a try for the next question. This is an easy question. I hope all of you can answer. See, in this question you are supposed to calculate the current flowing through 2 ohm resistor, right? Here you are having the 2 ohm resistor. In this particular resistor, how much current is flowing? Whether the current is flowing from A to B or B to A, that is the question. You are having the choices like that, right? So here if you observe, this 36 ampere is coming like this. 36 ampere is coming like this. After that you are having the resistors connected in parallel. Whenever elements are connected in parallel, obviously in parallel voltage will be same, but whatever the current is entering, the entering current will get distributed across the elements. That means now we are using current division rule. Okay, now we are applying current division rule. Okay, whenever elements are connected in series, that time we can apply voltage division rule. Whenever elements are connected in parallel, we can apply current division rule, right? So here entering current is 36 ampere. So we have to calculate the current flowing through 2 ohm resistor. Okay, so here entering current is 36 into now here we have to calculate the current flowing through 2 ohm resistor. That means opposite arm resistance we have to consider. Okay, other arm resistance we have to consider, that is 1 divided by sum of the resistances, 2 plus 1. See, in voltage division rule, when the elements are connected in series, what is the supply voltage there that we are considering in the numerator? In the numerator, across whichever resistor you are supposed to calculate the response, that resistance you are considering. But here, opposite resistance you are considering. Denominator is sum of the resistances as it is. Okay, so 2 plus 1 is nothing but 3. So 36 divided by 3 is nothing but 12. So units are ampere. Right. So here the current is flowing between the terminals A and B in the 2 ohm resistor. Okay, so that means option A is the correct one. 12 ampere is flowing from A to B because current is entering like this, right? This current is going in these 2 branches like this. Yes or no? In these 2 branches like this is flowing. And similarly, if you apply KCL at this node, in these 2 branches currents are entering, the entire current is going like this. Okay. Next question, all of you give a try. So here in this question, you are having the circuit diagram like this, right? Here in this question, you have to calculate the current flowing through 7 ohm resistor, right? 7 ohm resistor is present here. In this branch, how much current is flowing? Okay, so just for variety, actually we have solved similar question also. If you observe earlier, few questions back, we have discussed similar model. Okay, just for variety, I am discussing this question in another model. Okay, so for the time being, let us calculate the equivalent resistance here. Okay, these 2 are connected in parallel. In parallel, we can get the equivalent resistance like this, R1 R2 divided by R1 plus R2. Here 3 into 7 divided by 10. Okay, so 3 7s are 21 divided by 10, that is nothing but 2.1 ohm. 2.1 ohm. Now this resistor, whatever you got single resistor, that resistor and this resistor both are contained in series, right? So this entire configuration you are getting how much? This entire configuration you are getting 2.1 plus 2. Okay, that is nothing but 4.1 ohm. 4.1 ohm. Okay, I hope all of you are getting clarity. Right. Now you are having one supply and then one single resistor. Right. Now you can use Ohm's law. You can use Ohm's law. With the help of Ohm's law, we can calculate the current. So the current I equal to the supply voltage is 82 divided by the equivalent resistance you got just now 4.1. So here, just to do the calculation simpler, you can represent like this. Okay. Here denominator you are having 0.1, right? 0.1. So this 4.1 we can write as 41 by 10. The 10 is going to the numerator. Okay. So here 41 2 times 2 into 10, that is nothing but 20 amperes. 20 amperes. Okay. That 20 amperes is coming up to here. Yes or no? Okay. That 20 ampere is coming up to here. Now once again you can use current division rule. That's all. So we have to calculate the current flowing through 7 ohm resistor. So that is nothing but the supply current is 20 into opposite arm resistance, right? So here you are having 3 divided by sum of the resistances 3 plus 7. So 3 plus 7 is nothing but 10. 10 here 2 times 2 into 3, that is nothing but 6 ampere. 6 ampere, right? So option C is the correct one. Okay, I hope all of you are getting the clarity. Based on the possibility, I am covering all the varieties so that whichever methods you feel convenient for solving the given question, accordingly you can apply and you can get the correct answer. Okay, right. Yeah, this is a very interesting question. Okay, in this circuit you are having one supply voltage and then you are having 4 resistors like this, and they have mentioned with respect to every resistor the current direction, and you are having 4 choices regarding the currents. Okay, this is a very interesting question. Right. Just now what are the model we have discussed? Based on the same model, first we can calculate the current I1. Okay. So just observe here. Just observe. Here in this question, you are having 12 ohm, 6 ohm, all are connected in parallel only, right? So just in order to make the calculation simpler, first we can consider 12 in parallel to 12 and then in parallel to 6. You can consider any combination. Okay. So for easy understanding, I have considered in order to do the calculation simpler, 12 parallel and then with 6. Okay. So 12 parallel to 12 is nothing but 6. 6 parallel to 6 is nothing but 3 ohm. That means this entire configuration, equivalent resistance is nothing but 3 ohm. Okay. 3 ohm you are getting, right? And here you are having 7 ohm. 7 ohm, 3 ohm, both are connected in series. So 7 plus 3 is nothing but 10 ohm. 10 ohm. Okay. So now you can calculate the current I1. Supply voltage is 60 volt. And just now we got the entire equivalent resistance is 10 ohm. Okay. So that means 6 ampere. Now you can observe the choices regarding I1. Regarding I1, you are having 6 ampere in 2 choices, right? So that means we can eliminate as of now option A and option C. Okay. Because I1 value you are getting 6 ampere. Okay. Now we have to figure out among B and D which option is correct. Okay. Now you can observe here I1 current is coming. Okay. So you can calculate in any particular one current because all the resistors are connected in parallel, right? So just for easy understanding, I want to calculate the current flowing in the 12 ohm resistor. Okay. That time in order to apply current division rule easily, okay. So earlier question we are having only 2 parallel resistors, but here you are having 3 parallel resistors. Now what you can do, if you want to find the current flowing in this particular 12 ohm resistor, whatever the other 2 resistors are connected in parallel, you can find the equivalent resistance so that you can easily apply current division rule. Okay, right. So here 6 and 12 are parallel connection. So 6 into 12 divided by 6 plus 12, that is 18. So 6 3s are 18, 3 4s are 12. That means 6 parallel to 12, that is nothing but 4 ohm. 4 ohm. Right. Now you can apply current division rule. So I want to find the current flowing through 12 ohm resistor. So here the entering current, that is nothing but I1. So in this case, I12 ohm is nothing but, according to this question, that is your I2. Okay, and the entering current is I1. Now opposite arm resistance, that means opposite resistance. So this entire equivalent is 4 ohm. So that you can substitute, divide by sum of the resistances, 4 plus 12, that is 16. Okay, I hope all of you are getting the clarity. In this way, whenever you are having more than 2 resistors which are contained parallel, that time in whichever branch you want to calculate the current, other than that resistor, remaining all the resistors, you just find the equivalent resistance, so that you can easily apply current division rule. Okay, right. I1 value just now we got 6 into 4 divided by 16. So here 4 times, and then 2 3 times, 2 times. 3 by 2 is nothing but 1.5 ampere. 1.5 ampere. Right. Now all of you tell me, the moment you got the current flowing through 12 ohm resistor is 1.5 ampere, the same 12 ohm resistor here also current in parallel. So that means here how much current is flowing? Obviously the same current will flow, because in parallel voltage will be same, right? So the moment you got like this, now you can easily represent I4 also same. And here you can observe 6 ampere current is entering, and in these two branches together 1.5 plus 1.5, 3 ampere is leaving. That means obviously here 3 ampere should leave, that's all. Okay, so in this way we can calculate I3 also. So here you can observe I2 and I4 are 1.5 and I3 is 3 ampere. So that means option D is the correct one, whereas option B is not correct. Option B, I3 value is same, but I2, I4 values are not same. Even you can apply this logic also. See, the moment you got I1 value as 6 ampere, okay, here for understanding purpose I have solved the question completely, but here you just observe the choices. The first step is you have calculated I1 value. The moment you got I1 value 6 ampere, we have eliminated A and C. And then just by observing the circuit diagram, here 12 ohm is there, here 12 ohm is there. So that means I2 and I4 should be same. Okay, so I2 and I4 are same in option D. But what about in option B? Option B, they are not same. Straight away you can eliminate. In this way, in SSC JEE questions, okay, in like this, in some of the questions if you observe, even though they are asking multiple parameters or multiple values, but the moment you have calculated one of the main value, with the help of that you can straight away eliminate the wrong choices. Okay, then because of that ultimately you are getting the correct answer. But whether you are getting or not, if you want you can continue further, then definitely you will be getting the same answer. Okay, in this way, in the SSC JEE exam, if you want to save the time, okay, after reading the question, okay, before solving, have a glance with respect to the choices. Just observe the circuit diagram and observe the choices, and from there you are getting the clue. With the help of partial solution only, you can easily attempt the correct answer. I hope all of you are getting the clarity. So in this way, in this series of lectures, wherever possible, I am giving all the hints, so that all of you try to adopt whichever hints is suitable for you while you are solving the questions. Try to adopt it. Definitely you can score more marks in the given time. Okay. Yeah, next question, all of you give a try. So in this question, we have to calculate the current flowing through 8 ohm resistor. In this question, we have to calculate the current flowing through 8 ohm resistor. Okay, right? In this particular branch, we have to calculate the current. Now, if you observe, say for example, I am labeling this particular node as B. Okay, so here can we apply source transformation? Yes, obviously we can apply. Okay, so if you apply source transformation, what you are getting here, 16 by 2, that is nothing but 8 ampere. voltage divided by resistor. Okay, 16 by 2 is nothing but 8 ampere, and then you are representing that resistor. Okay, 2 ohm. So this is the circuit you are having between the terminals A and B. Between the terminals A and B. Okay, and then whatever the circuit here you are having, you can draw as it is. So here we are having 4 ohm resistor and then 8 ohm resistor. Four ohm, 8 ohm, right? Now here in as per the question we have to calculate the current flowing through 8 ohm resistor. So that means just now we have told, okay, we can get the equivalent resistance whenever you are having more than 2 resistors like this. If you want to find the current flowing in one particular branch, okay, you can find the equivalent resistance. So R1 R2 by R1 plus R2. So 2 into 4 divided by 6, 2 3 times. So from here you are getting 4 by 3 ohm. Okay, no need to simplify because you are having choices like ratio of 2 numbers other than option A, right? So now you can apply current division rule. I want to calculate the current flowing through 8 ohm resistor. So that is nothing but entering current is 8 ampere. Then opposite resistance is 4 by 3 divided by sum of the resistances. Okay, 4 by 3 plus 8. So here you can do the LCM, you are getting 3. So from here I am writing 8 into 4 by 3 divided by, here LCM you are getting 3, then 4 plus 8 3s are 24. 8 3s are 24. Okay, so here denominator 3 are getting cancelled. Okay, after that you are getting 8 into 4 divided by 24 plus 4, that is 28, right? So 4 7 times, right? So that means you are getting 8 by 7. 8 by 7 units are ampere. Okay, so option D is the correct one. See, in this way, if you observe whatever the questions we are covering in this particular session, all these questions are very interesting questions. Okay, based on the possibility, I am covering all the variety of cases with respect to KCL, KVL, and equivalent resistance, current division rule, etc. So even source transformation, right? I hope all of you are getting the glimpse. Okay, right? Yeah. Next question. In this question, you are having the circuit diagram like this. Okay, so here you have to calculate the current flowing through 4 ohm resistor. Current flowing through 4 ohm resistor. Here you are having 4 ohm resistor. In that particular resistor, how much current is flowing? That is the question. Okay. All of you give a try. Any guess which method you want to apply? Here just observe, in this particular branch you know the current. Okay, in this branch you don't know the current, in this branch you don't know the current. Directly better you can use nodal analysis. Okay, so for the time being I am assuming this node voltage as, okay, so generally we are considering this node to the ground. Okay, this is the reference point or reference node. Okay, this node voltage with respect to ground. Okay, for the time being I am labeling as V1. This node voltage with respect to ground as V1. Okay, so since you don't have the current, you can assume that current is leaving. Similarly, in this branch, current is leaving. In this branch, already they have mentioned current direction like this. You can just apply nodal equation. That's all. Just apply nodal equation. Okay, so in this 2 ohm resistor, the current flowing is V1 minus 20 divided by 2 ohm. Then similarly here V1 by 4, V1 by 4, and in this branch 15 ampere is leaving. So sum of all the leaving currents equal to 0. Okay, now you can do the LCM, or otherwise overall equation you can multiply with 4. If you are multiplying overall equation with 4, then 2 times V1 minus 20, then V1 plus 4 into 15, that is nothing but 16. 60 equal to 0. 4 15s are 60 is equal to 0. I have multiplied entire equation with 4. Now you can do simplification. 2v1 plus v1, that is nothing but 3v1. Next, minus 40 plus 60 is equal to 0. Okay. So 60 minus 40 is nothing but 20. If you bring 20 to the right hand side, it will become negative. So from here you are getting 3v1 equal to minus 20. So from here you are getting v1 equal to minus 20 by 3. Units are volts. Units are volts. Okay, v1 value we are getting negative. Okay, and suppose here let us consider the same voltage. Okay, so here 4 ohm resistor is there. Okay, suppose I am labeling here the current flowing like this is I4 ohm is equal to v1 is minus 20 by 3 divided by the resistor value is 4. So from here you are getting minus 5 by 3 ampere. Right. So in this question, if you observe between A to B, the current value is negative. Okay. Do we have any option negative? No. So that means since the current direction, if you are considering A to B, because you got negative, okay, from B to A, obviously you will be getting positive. Right. So just observe the option with respect to B to A. Yes, whatever minus 5 by 3, now it will become positive 5 by 3 ampere. Okay. In this way, you have to choose the answers accordingly, right? Okay. Yeah, next question. All of you give a try. In this question, you have to calculate the current flowing through 12 ohm resistor. Current flowing through 12 ohm resistor. So here you are having 12 ohm resistor here. In this particular 12 ohm resistor, how much current is flowing? That is the question, right? So here also you can apply nodal analysis. Okay. So for the timing, just like the earlier question, I am considering reference node, that is ground. Okay. And this node voltage with respect to ground. With respect to ground, I am labeling, for easy understanding, I am labeling as V1. V1. If you want, you can consider VA, no issue. Okay. So here in this branch we don't know the current, you can assume that leaving. Similarly here leaving, and in this branch also we don't know, you can assume that current is leaving. Okay. Just apply nodal equation. So here you are getting V1 minus 36 divided by 3. V1 minus 36 divided by 3, and then V1 by 12. V1 by 12. Then here it is the most important thing. Generally students will do silly mistake here. Okay. If you are having any confusion here, okay, what you can do, this voltage source you can keep here. This voltage source if you keep here, then what will happen? Here, if you are keeping this voltage source here, you are having what? Minus 24, correct? So you are writing just like here, VA minus 36 by 3, right? In a similar way, here, V1 minus of, okay, this voltage source when you have kept here, you are getting what? Minus 24, minus 24. This is the most interesting thing, most important thing. Okay, divide by 4 ohm. Okay, sum of all the leaving currents equal to 0. Okay, I hope all of you are getting clarity. See, when you are having the source here, you don't have any problem, right? While you are applying Ohm's law in order to find the current. Same way, if you are facing any problem because of this voltage source, because ultimately these two are connected in series, you can consider resistor first and then voltage source. No issue. The moment you have kept voltage source here, okay, because it was having minus, it is having minus here and then plus here, then accordingly I am considering the same voltage source polarity. So V1 minus of, because it is minus, okay, because you are having minus polarity, minus 24. Okay. So this overall equation, for the timing I am multiplying with 12. Okay, if you are multiplying with 12, then 4 into V1 minus 36, then V1, then here 3 times into V1 plus 24 is equal to 0, is equal to 0, right? So 4V1 plus V1, that is 5 plus 3, 8. 8V1, then 4 into 36, 4 6 are 24, then 4 3 are 12 plus 2, that is 144. Okay, then here 3 into 24, that means you are getting 72 is equal 0. From here you are getting 8V1 is equal to 72. So from here you are getting V1 equal to 9 volts. V1 equal to 9 volts. But in this question you have to calculate current flowing through 12 ohm resistor, right? So just now you got V1, now we can calculate the current. Current flowing through 12 ohm resistor by using Ohm's law, 9 divided by 12. So 3 3s are 9, 3 4s are 12, 3 by 4 is nothing but 0.75 ampere. 3 by 4 is nothing but 0.75. So the correct answer is option D. Option D. Okay, I hope it is clear for everyone. Here in this question you have to take care regarding this particular branch. If you are able to write the current expression correctly, definitely you will be getting the correct answer. Next question. In this question you have to calculate the current flowing through 20 ohm resistor, just like the previous question. Just like the previous question. In this branch we have to calculate the current. So we can solve once again by using nodal analysis. Okay, just like the earlier questions, I am considering this node as ground or reference. Then this node voltage with respect to ground I am labeling as V1. Okay. Once again you can apply nodal equation. V1 minus 10. V1 minus 10 divided by 2 plus, in this branch V1 divided by 20. V1 divided by 20, and now you can observe just like whatever in the earlier question I have discussed, this minus 24 volt I have kept here, right? Like that here you are having. Okay, when you are having like this, you won't get any confusion, right? Yeah, V1 minus of minus 20, V1 minus of this voltage, okay, minus 20 divided by 4 is equal to 0. Right, in this equation, overall equation you can multiply with 20, then from there you are getting 10 into V1 minus 10 plus V1. Here when you are multiplying with 20, 4 5 times, right? 5 into V1 plus 20 is equal to 0, is equal to 0. Okay, so here 10 times, then 1 time, then 5 times. 10 plus 1 is 11, 11 plus 5, 16. 16 V1, then minus 100, right, here plus 100. Minus 100 plus 100, both will get cancelled. So for easy understanding, I am writing one time. Minus 100 plus 100 is equal to 0. So from here you are getting 16 V1 equal to 0. From here you are getting V1 equal to 0. The moment you are getting V1 is 0, okay, obviously the current flowing through 20 ohm resistor will be 0. That's all. The current flowing through 20 ohm resistor is 0 by 20, that is nothing but 0 ampere. Okay, right. So the answer for this question is option B. Option B is the correct answer. Yeah, up to now, what are the questions we have discussed? That is with respect to first chapter. Now we are entering the questions. We are entering the second chapter. We are solving the questions based on second chapter. That is network theorems. Okay. So all of you give a try. All of you give a try for this question. So this is a theoretical question based on superposition theorem. This is a very interesting question. So here in this question, they have mentioned that superposition theorem is applicable for the calculation of, okay, you are having 4 choices like this, obviously one choice will be correct. Okay, for this question few students may choose option D, but option D is not the correct one. Option D is not the correct one. The reason is whenever you are having voltage expression, okay, voltage expression you are having what? V equal to I into R. Okay, so that means there you are getting with respect to voltage or with respect to current, you are having the linear relation or the first order. Okay, but coming to the power equal to V into I, but after that if you are getting the derived versions, so you can write in place of V I into R, then accordingly you are getting I square R R. In place of I, if you are writing V by R, accordingly you are getting V square by R. Now what is your observation with respect to power and current, or with respect to power and voltage? Here you are having power 2. Okay, whenever you are having power 2 or 3, 4, etc., that time that particular quantity is not linear, right? So we can apply superposition theorem only for the linear circuits. That is the reason here we cannot apply superposition theorem directly for calculating the power. Directly we cannot calculate the power by using the superposition. Okay, so that means here the correct answer for this question is option B. Okay, because here you are having power, so all these choices straight away can eliminate other than option B. Okay, right. So here option B is the correct one. You can observe superposition theorem is applicable for the calculation of voltage and current, but not power. This is the most important thing. But generally few people may apply superposition theorem directly. Okay, and they will be saying that P equal to P1 plus P2. Say for example in case 1 you got P1, case 2 you got P2, now they will be adding, but that is not correct. We cannot apply superposition theorem directly for calculating the power. But if you want to calculate the power across a particular resistor, if you want with respect to case 1, case 2 you can calculate the currents, after that resultant current you can consider, after that you can use this formula. Similarly with respect to voltage, like that you can calculate, but you should not apply like this. Okay, yeah. Next question. So in this question we have to calculate the voltage across this particular 1 ohm resistor. Okay, so you can solve this question by using nodal also. Okay, but here currently I want to solve this question based on superposition theorem, because currently we have entered in the second chapter and we have discussed good number of questions based on nodal analysis earlier. Okay, in your free time, what are the questions earlier chapter we have discussed, based on the possibility, whichever questions we can solve by using superposition theorem, all of you can try in your free time. Okay, right. So here with respect to superposition theorem, okay, just you can observe, we can apply superposition theorem whenever you are having multiple sources present in the given circuit. Okay, so say for example in case 1 I am considering 5 ampere source. Okay, here in this overall circuit you are having two sources, one is current source, another one is voltage source. Okay, so in case 1 I am considering only this current source. Okay, that time I am shorting the voltage source. Okay, so when you are shorting the voltage source, right, that time what will happen? Okay, I am not drawing the equivalent circuit. Okay, just for reference I am mentioning, I am considering 5 ampere current source in case 1. That time I am keeping the voltage source as short. Okay, the moment you have kept voltage source short, here 1 ohm connected in parallel, right, and here 5 ampere current is entering. Now you can apply which rule? Which rule we can apply? Current division rule. That's all. See, the moment if you are applying theorems, once again you are using the basic laws of the previous chapter. That's all. Okay, right. The moment here you have shorted, these two are connected in parallel, right? Here 5 ampere is entering, and since both the resistors are having the same value, obviously the current flowing through 1 ohm resistor is, okay, current flowing through 1 ohm resistor is 5 by 2, that is nothing but 2.5 ampere, and by using Ohm's law you are getting the voltage across 1 ohm resistor is 2.5 into 1, that is nothing but 2.5 volts. This is case 1. I hope all of you are getting the clarity. The moment you have applied superposition theorem with respect to case 1, you no need to use pen and paper in order to get this value. Okay, I hope all of you are getting the clarity. You can visualize whatever the considerations you are considering, you can do in the circuit diagram. Instead of drawing, you just visualize there, from there direct step you can write. Okay, now I am considering case 2. Now in case 2 I am considering the voltage source. Okay, I am considering the voltage source. Now in this case what will happen? The current source we have to make it as open. Okay, the moment you have made current source open, there is no current flowing through 17 ohm resistor. So in that case these three elements are connected in series. That's all. Okay, so here just for reference I am mentioning, like here you are having minus plus 2 volt, and then 1 ohm resistor you are having. Okay, so here for easy understanding I am representing like this. Okay, you are having 1 ohm resistor. Okay, these two are connected to this particular supply. Okay, just like here, when you have applied current division rule, because both are having equal value, half of the total current is flowing. In the similar way, what is supply voltage you are having, half voltage you are getting here, other half voltage you are getting here, because you are having equal resistances, right? Now with respect to this one, you can observe here, according to this example, the plus sign you are having here and then minus sign is present here according to this context, right? So here I am considering, okay, V1 ohm is equal to minus 1 volt, because here polarities are opposite, okay. For easy understanding, I am considering this is the case 1 voltage and this is the case 2 voltage, okay. Now in both the cases I have considered the voltage polarity same, right? Now by using superposition theorem, we have to add the resultant voltages, okay. By using superposition theorem, we have to add the resultant voltages. By using superposition theorem, okay, in order to find the resultant voltage across 1 ohm resistor is nothing but V1 plus V2, V1 we got 2.5 plus V2 we got minus 1 volt, So 2.5 minus 1 is nothing but 1.5 volt, 1.5 volt, right? So the answer for this question is option C. I hope it is clear for everyone. Yeah, next question, all of you give a try. This is the question based on Thevenin's theorem, okay. So in this question they have mentioned that the Thevenin's equivalent voltage, here in this question they are asking voltage, Thevenin's equivalent voltage across the terminals A and B, So here you can observe you are having the terminals A and B, right? But across the terminals A and B you are having one resistor, okay. Now whenever you are supposed to find the Thevenin's equivalent voltage or Thevenin's equivalent resistance, okay, so that generally in most of the questions they will keep the terminals open, but in some questions they can keep the load resistor like this. Whenever they are keeping the load resistor like this, if you want to find the voltage or if you want to find the resistance across the terminals, now you have to remove this particular load resistor from the circuit. The moment you have removed the resistor, then terminals will become open, okay. After you have removed the resistor from the circuit, then terminals will become open. Across the open circuit terminals you are having the voltage VTH, right? Okay. Now the moment here terminals open, okay, I am not drawing the equivalent circuit just to save the time, okay. And I hope by this time you all got the familiarity. That is the reason you can visualize here only, and I am giving the shortcuts here, how easily we can solve the questions even based on network theorems in the given time, okay. How you have to visualize, like that approach I am telling here, okay. If it is regular class, I will be drawing the equivalent circuit and then step by step I am drawing, but now this is the time you people are doing the revision or recall, okay, because your exam is very nearby, right? That is the reason how to visualize the given circuit and how to do the calculation without using pen and paper, that approach I am discussing. And that too we have discussed already 2 sessions earlier, and in the first session and second session I have discussed very slowly and you people got enough command and over the basic concepts, right? Now once if you are getting very good command, now we are solving the questions in second chapter, you should increase the speed, okay, right? Yeah. So the moment you have removed the load resistor, here terminals A and B become open, that means there is no current flowing here, If there is no current flows here, all right, whatever the 20 ampere current is flowing here, the entire 20 ampere current is going like this. This is forming a closed path, that's all, okay. Now by using Ohm's law, you are getting the voltage across this 4 ohm resistor is 80 volts, 20 into 4, okay. Now you can apply KVL around this particular closed path, okay. You can apply KVL or whatever the earlier concept we have discussed with respect to unknown. In order to find the unknown voltage, we can use the polarity concept, okay, just for easy understanding, okay. Here I want to get between the terminals A and B, right? So whatever other you are having, I am representing here. Plus minus 80. Okay. So this terminal, both are same, terminal A only, right? Plus minus 80 volt as it is. Now whatever this 20 volt here you are having, minus plus. Okay. For the time being, this voltage source I am keeping vertical element. The moment I am keeping vertical element, you are getting voltage polarity, sir, plus minus 20 volts. I hope all of you are getting the clarity. Just for reference, I am mentioning this terminal as A and this terminal as B. Okay, right. Now you can observe polarities are same. Whenever polarities are same, we can add the voltages. 80 plus 20, that is 100 volt. So this is nothing but your VTH. That's all. Okay. So option B is the correct one. Option B is the correct one. Yeah, next question with respect to Norton's theorem. Norton's theorem can be applied to. All of you give a try. All of you just read the choices once and try to choose the correct option. Yeah, just observe here in option A you are having non-linear. We can eliminate. We cannot apply Norton's theorem for non-linear. We can apply Thevenin's theorem and Norton's theorem for linear and bilateral networks. Okay. So here linear is there, but here non-linear is there, right? So since non-linear is there, here also we can eliminate, and here non-linear is there, we can eliminate. Only the leftover option is D. Okay, that is linear network. Even if bilateral mentioned, that is also applicable. Okay, we can apply Thevenin's theorem and Norton's theorem for linear and bilateral networks. Okay, right. The next question here, the Norton's equivalent current they are asking. This is also very interesting question with respect to Norton's. Okay, see, whenever you are calculating the current, that time we have to short the terminals. Here with respect to the terminals A and B they are asking. With respect to terminals A and B, they are asking the Norton's equivalent current, right? So here we have to short the terminals A and B. Here we have to short the terminals A and B. After shorting the terminals, whatever the current is flowing in this short circuited terminals, that is nothing but your Norton's current, right? Suppose if they are asking to calculate Thevenin's voltage across the terminals, you are calculating the open circuit voltage. Across the terminals, you are calculating the equivalent resistance. Okay. Regarding equivalent resistance, we have to keep the terminals open. Whenever we are supposed to calculate the current, obviously current will flow in the closed path. That is the reason we have to short the terminals. Okay. I hope all of you are getting the clarity. Right. The moment you have shorted the terminals, okay, this node voltage and this node voltage both are same. Now, here you are having 0 voltage. The potential difference or voltage difference is 0. So that means here there is no current flowing here. That's all. In this 15 ohm resistor, there is no current flowing. Now, the moment here you have observed like this, just here you are having 10 ampere current is entering, and here you are having 5 ohm resistor, and because in this branch there is no current flowing, okay, so you can consider the other path is like this only. Yes or no? Right. So here 5 ohm and here 5 ohm. Okay, whatever the 10 ampere current is there, half of the total current is flowing in this branch, other half is flowing like this, right? So now you are using current division rule. That's all. Obviously the first chapter concept. Okay. So the entering current is 10. Because these two resistors are having same value, half of the total current, 10 by 2, that is nothing but 5 ampere. 5 ampere. So option B is the correct one. Option B is the correct. Next question, very interesting. This is even more interesting. All of you give a try. So in this question, we have to calculate the Norton's current between the terminals A and B. See, in the earlier question, they have kept terminals A and B initially open, so we have shorted. But in this question, between the terminals A and B, they have given one resistor. Now, because you have to calculate the equivalent resistance, equivalent current, right? Not an equivalent current. In this question, we have to short the terminals A and B. We have to make the short, right? We have to short the terminals. Okay, the moment you have shorted, you are having one voltage, you are having one resistor. That's all. Okay, in this shorted terminal, how much current is flowing? That is nothing but your IN. Okay, so that is equal to supply voltage is 10 divided by resistance is 4. 10 by 4, that is nothing but 2.5 ampere. This is the most important thing. See, in the SSC JEE exam, they are checking whether you are strong on the basics or not. Okay. Yes, option C is the correct one. Once if you are able to apply open circuit voltage, means we have to keep the terminals open whenever the load resistor given. Okay, whenever the load resistor given, that load resistor we have to remove. Similarly, whenever you have to find the equivalent Norton's equivalent current, here in this case this 14 ohm resistor is like load resistor. Okay, we have to remove that load resistor and then we have to short the terminals. That is the most important. Yeah. Next one, this is also interesting question. So in this particular question, whatever in this particular session, all the questions are very interesting. Okay, in the first chapter, in order to cover all the variety of models, I have selected the questions accordingly. Even in this particular network theorems chapter also, you are getting all the interesting questions and variety of questions as well. Okay, so here just read the question carefully. Here you are having a two-terminal network connected to a resistive load network. Okay, a two-terminal network is connected to a resistive load. Okay, so here resistive load I am considering, resistive load means you are having one resistor. Okay, load resistor I am considering like RL, but here that load resistor value mentioned as that particular resistance value is equal to 2 times the Norton's resistance, 2 times Norton's resistance, right? So RL equal to 2 times Rn, 2 times Rn, right? Now the question is, see, whatever the two-terminal network you are having, that entire two-terminal network in this question, because they have framed the question with respect to Norton's resistance, now you can represent that other part of the circuit, equivalent circuit, you can represent as a Norton current in parallel to Norton resistance. Okay, I hope all of you are getting clarity. Now this is the equivalent circuit. If they have mentioned in terms of Thevenin's equivalent, you could have represented a Thevenin's voltage in series with resistance. Okay, right. Now the question is, here what will be the load current? Okay, so the load current IL we have to calculate. This is the load, right? In this resistor, how much current is flowing? That is the question. What will be the load current if the Norton's current is IN? You can observe when you have read the complete question, from there you are getting the hint. So that two-terminal network we have to replace as practical current source, that is nothing but a current source in parallel to resistor. Okay. Now the moment you got the circuit like this, it is dead easy question. But only the twist in this question, they haven't given the circuit diagram, but after reading the question you have to draw the equivalent. Once if you are able to draw the circuit, then after that question is nothing, you can easily solve. Okay, so now you are using which rule? Current division rule, right? Very good, current division rule. So here by using current division rule, the supply current is IN into, in this branch we have to find the current, so that means opposite resistance we are considering, that is Rn, divided by sum of the resistances 1 plus 2, that means 3 times Rn. So here Rn will get cancelled, so you are getting IN by 3, right? So that means option B is the correct one. Option B is the correct. Yeah, next question. All of you give a try. This is a question based on maximum power transfer theorem with respect to efficiency. If a source is delivering maximum power to a load, okay, the power transfer efficiency of the circuit, how much? Yeah, some of you are saying 100%. No. When you are using maximum power transfer theorem, efficiency at max you are getting 50%, right? 50%. Option D is the correct one. Okay. Yeah, next question. This is a question once again based on maximum power transfer theorem. So here in this question, you are having the circuit diagram like this, right? Here, in order to get the maximum power across the load resistor RL, okay, you have to find out the RL value, and how much maximum power you are getting across the load resistor. That is also they are asking. Okay, you can observe the choices. You are having RL value and then the maximum power across the load resistor as well. Okay, so in order, I hope all of you know regarding in order to get maximum power across the load resistor, right, RL should be equal to RTH. That means you have to remove the load resistor from the given circuit, then terminals will become open. So then across the open circuit terminals, you are calculating RTH, right, after removing the load resistor, right. Now in order to find the RTH, yeah, here the voltage source we will make it as short. If you are having current source, we will make it as open, right. That time this 30 ohm and 150 ohm both are considered in parallel, right. So RTH equal to 30 into 150 divided by 30 plus 150, that is directly I am writing 180. So here 30 6 times, okay, and then here 6 25 times. So the answer is 25 ohm, that is RTH. Okay, in order to get maximum power across load resistor, the condition is RL equal to RTH, that is nothing but 25 ohm. So in this question, the moment you got 25 ohm, that is there in only one choice, straight away you can choose. You are lucky, right? Even though they ask you to calculate both the parameters, but the moment you got one parameter, okay, that one parameter exactly it is there in only one choice. With the help of that, straight away you can choose. But suppose in the given choices, some of the choices are matching with the help of first parameter, then that time what you have to do? You have to calculate the other parameter also, right? So that time, in order to get maximum power across the load resistor, okay, I hope all of you know the formula, VTH square divided by 4 times RTH. RTH value just now we got, now we have to get the VTH, okay. So VTH is nothing but, see, you have removed the load resistor, then terminals become open, then now you are applying what? Voltage division rule, that's all. See how much beauty it is. The moment if your basics are strong with respect to first chapter, when you are solving the questions of second chapter, you are applying those basics only, right? So because here terminals become open, there is no current flowing. Whatever the current is flowing, the entire current is flowing like this. That means all these elements are connected in series. In series, current will be same. Voltage is getting divided, that's all. So here supply voltage is 180 into, across this resistor we want, that resistor is coming into the numerator 150 divided by sum of the resistances, that is 180. So here 180 are getting cancelled, you are getting 150 volts. 150 volts. Now you can use the standard formula in order to get the maximum power across the load resistor, that is nothing but PL max. Okay, in this question it is mentioned P max. Okay, so that same notation you can use, no problem, is equal to VTH square divided by 4 times RTH. VTH square divided by 4 times RTH. Okay, so VTH value just now we got 150. So for the timing I am representing as 150 into 150. Okay, divided by 4 into 25. So 425 sir 100. Yeah, sorry. 425 sir 100. So here 10 will get cancelled, another 0 will get cancelled. That time you are getting 15 into 15, that is nothing but 225 units sir watts. Okay, so in this way we can calculate. Suppose if two choices are satisfying, then in that case we have to use the standard formula. But in SSC JEE exam, since you are having less time, so in most of the questions when I have observed, with the help, even though they are asking to calculate two parameters, but with the help of one parameter, you are straight away you are able to choose the correct option, because in other choices they have given different values. But suppose if two options are satisfying, then definitely you have to solve. Okay, but here in this case definitely it is taking time, right? So that is the reason they are keeping some inherent logic here in the choices. Okay, that is the reason you have to read the question and then you should be smart whether among the given two parameters, which parameter you are having in all the choices different, better calculate that parameter. In that way you can save the time in the GATE exam, okay, in the SSC JEE exam. Okay, right. Yeah, so in this particular session we have discussed the variety of questions which are asked in the SSC JEE previous year questions, right, previous years. With respect to network theory subject, we have discussed the questions based on KCL, KVL, and then current division rule also, and with the help of node analysis we have done, and even wherever required we have applied source transformation, and then even we have discussed the some of the questions based on network theorems. In the further session definitely we will be continuing further questions based on network theorems and then upcoming chapters as well with respect to SSC JEE previous year's questions of network theory subject. Okay, so I hope all of you got the maximum benefit from this particular session. I hope this particular session meant a lot for all the aspirants of SSC JEE exam, especially whoever writing in the next month. Okay, right. So once again I am giving whatever the one important update I have mentioned at the beginning of today's session. Once again I am repeating. So this is our Telegram channel, right? So all of you kindly join our Telegram channel IMS GATE Academy. Regarding this particular link already provided in the description of this particular video. Okay, so whoever not yet joined till now, all of you kindly join, because in this Telegram channel you are getting all these features for free of cost. Okay, you are on daily basis you are learning one quiz question. Okay, you are learning one question of the day, like that. Okay, so all these benefits you are getting for free of cost. All of you kindly join if you not yet joined. Okay. And one more important that I am giving for all of you. Okay, here at our IMS GATE Academy we are offering live online program for the GATE aspirants whoever writing the GATE exam in 25 or 26, right? So all of you kindly contact to any of these two numbers, right? Our counselors will discuss in detail about our live online program, right? After that you can enroll based on your interest. You can enroll for the live online program, because here whatever the resources required for all the GATE aspirants whoever want to get very good ranks in the upcoming years, right, we are providing each and everything. You can observe here the number of live classes we are providing and the number of practice questions we are providing, and even the GATE question bank along with the solution 34 plus years, right? And then 130 plus online tests we are providing, and not but not the least we are providing 12 my plan sessions for all the enrolled students, right? All these benefits you are getting. So your preparation, if you want to make smoother, better enroll at our IMS GATE Academy, right? For more details contact to any of these two numbers. Our counselors will discuss in detail. Okay, yeah, thank you everyone. So all of you kindly subscribe our YouTube channel if you not yet done, and all of you like and share this video link with all of your friends, so that this particular series of lectures whatever we are doing with respect to SSC JEE previous year questions regarding network theory subject, this particular series of lectures are going to help a lot for all the SSC JEE aspirants, right? So all of you try to share to maximum number of your friends and juniors, even for your seniors as well, right? So we'll meet you all in one of the upcoming session. Thank you everyone.